All right, we got two more examples. Do I need to write it up? I'll write it up here. Here's D. What else could the circles look like? We got two not touching, two touching one place, two touching two places.
They're completely on top of each other.
Very good. Good math word. Concentric. Looks like a target, right?
Oh, gosh.
Two circles inside of one another, which I think is what you meant. Two circles inside of one another, right? One's inside of. How many common tangents do those have?
0.
Can't draw any.
1.
If I draw a tangent on that, it's a secant to the big one. If I draw a tangent on that one, it's not on the little one. So the answer is 0. There are no common tangents. Okay, these are 5 things you need to study so that when you see it on the test, you find the right answer and you put it in. Okay? All right, your last example. Everybody have an idea what I should draw for my last example?
Then, like,
Two circles that touch where?
every,
That would be a good one. That's on top of one another. Here's one circle. Here's the other circle. They touch right there at one place. So how many common tangents do they have?
1.
One. Exactly right. One common tangent. Okay, and that's it. That's common tangents. You need to know these 5 scenarios. Okay? It gets a little confusing. Are these external or internal? External. This one didn't have any. Is this one external or internal? It's kind of both. It's a little confusing. We're going to say external. Okay. Hopefully they won't ask you that one, but that one's external. Okay. Questions? All right. Now let's talk about the theorems. We got 2 theorems to talk about. Like I said earlier, I do not care that you understand or remember the name of the theorem. What I want you to know is the material in the theorem. What is the theorem saying? All right. Theorem 6.1, you've got a circle. You've got a ray or a line that is tangent. And you have a radius, meaning it comes down here to the center of the circle. This is 6.1 right here. I'm talking about theorem 6.1. If I connect the center and the endpoint of that segment, I will get a right triangle. Meaning this angle has to be a right angle, because what does it say in the theorem? It says perpendicular. Right? What is the definition of perpendicular? Perpendicular lines do what?
Cross at a right angle.
They cross at a right angle. They form 4 right angles. So if it says that in a plane a line is tangent to a circle if and only if the line is perpendicular to the radius of the circle at the end point of the circle, all that means is this radius and this line tangent, I'm just going to put a T there for now, the tangent line intersect at a right angle. So how are they going to get questions out of this? Well, this makes a right triangle, which we have all kinds of theorems. We could use sine, cosine, and tangent. We have all kinds of information that we can do. Let's look at one. Let's look at 9, 12, and x. 9, 12, and x. If this x represents this whole side, how would you find it? Pythagorean theorem, which is, Taylor? Our shorthand way of doing that, what would we type in our calculator? The square root of 9 squared plus 12 squared. Why is it plus?
Because you got 2 letters.
What are you trying to find? You're trying to find the hypotenuse. When you're trying to find the hypotenuse, it's plus in the middle because you got 2 legs. So this is the square root of 81 plus 144. The square root of 225, which is what? 15. So x equals 15. So using theorem 6.1, understanding that it makes a right triangle, we can use the Pythagorean theorem in order to go backwards and find x. Okay? Questions? Any questions? All right, let's do another one. Where does the right angle go? Does it go here or does it go here?
It goes there.
The top or the bottom?
Second one.
Always goes here.
That's not
Because
right.
of the tangent.
That's right. The radius and the tangent make a right angle. All right, let's see if I can get this right.
That's a crooked looking right angle.
I know, I'm going to move. You want to set it up? We're finding x. Okay.
2 squared minus 3. No, 2 squared plus 3 squared. What? I'm so confused. Where's the thing at?
Okay. Yes. We're confused a little bit. Why? There's a missing part, right? 2 is not the side of any triangle. Right? They love doing this. This is what I just talked about earlier.
5.
4 is the correct answer. Let's talk about how we got there.
Did you double it if it's already 5 9?
What?
I don't know how I got 4. I just guessed.
If this amount here is 3, then what does this amount here have to be? It has to be 3 as well, right? Because why? They're both radiuses. I talked about that earlier, right? So that means that my entire hypotenuse from there to there is how much? 5. 2, you cannot use 2 as the side of a triangle because it's not the side of a triangle. Okay, it's part of a side of a triangle. So if I'm now solving and I have the hypotenuse and I'm trying to find a leg, then I set it up as what?
5 squared minus 3 squared.
5 squared minus 3 squared, which is the square root of 16, which is 4. X equals 4. X equals 4. Okay, questions? Any questions? Yeah. Yeah, go ahead. Go ahead. Get your planner. Let me sign your planner. That's fine. I'll turn it on. All right. We got one more concept, and then we're going to try some problems. The last theorem here. Read it out for me, Taylor. Theorem 6.2.
Okay. Tangent segments from a common external point are congruent.
All right. So here's a circle.
You want me to man the camera?
No, hold on just a second. What's today's date? The 26th. I'm going to say Gloria Smith, 12 o'clock. Okay.
All right. So here's a circle. Here's a common exterior point. I'm going to go from A, and I'm going to come down here, and I'm going to touch a circle at a tangent point. I'm going to come from A, and I'm going to come to the circle, and I'm going to touch it at a common tangent point. Here's B, and here's C. What is the theorem? Now that I've drawn it for you, what is the theorem saying? Can you put it in your own words or in letters, in terms of letters?
To connect it.
Read it again. Tangent segments from a common exterior point are what? They are congruent. So I could say BA, line segment BA is congruent to line segment CA. Right? They are congruent. Why? Because of this theorem. The theorem tells you that they are congruent. You don't have to prove it. You can just accept it as fact. If these two segments are congruent, how are they going to get problems out of that? Well, they're going to say 2x plus 1, and they're going to say x minus 1, and ask you to solve. All you have to do is do what?
2x plus 1 equals.
Set them equal to each other and solve. So 2x plus 1 equals x minus 1. Over here I get x. Over here I get negative 2. Okay? So x equals negative 2. So very simply, you just have to memorize that formula. By itself, no, it's not very hard. But when I put it next to one of these other problems, and I put it next to a different problem from tomorrow, from Wednesday, then it's a little nugget of information that you have to remember. Okay? Questions? Any
How do
questions?
we know if, like, you know what I mean? Like, how do we know if they're congruent?
It tells you that they're
What
congruent.
if this little thing was right
Wait,
here?
Hold on,
how'd
don't-
you get
hold on.
negative 2?
You're saying if this wasn't tangent? You're exactly right. In the given, in the directions, it has to say that AB and CD are tangents.
Okay.
It has to
so
tell
it has
you
to
that.
tell you that. If they just give you two random lines.
Right.
it's
You
not-
don't know that they're tangent. They have to set it up for you so that you can use the theorem.
Okay, so they're going to say.
Never mind.
They're going to say that. Did that answer your question?
No,
Okay.
but
Questions?
I was doing it wrong.
Say it again. I